Dear students, yesterday we discussed about the standard equations of this ellipse, how to find the coordinates of foci, this foci, vertices, lattice rectum, eccentricity of the ellipse, which are in standard forms. Now let me consider another equation like 4x square plus 9y square equals to 36. So firstly we will convert this form into the standard form, which is either x square plus a square plus y square upon b square equals to 1, or x square upon b square plus y square upon a square equals to 1. So here in RHS there is one coefficient or constant is 1, so here 36. So let us divide 36 on both sides. We simply get 4x square plus 9y square upon 36 equals to 1. So break this denominator, that is 4x square upon 36 plus 9y square upon 36 is 1, or simply x square upon 9 plus y square upon 4 equals to 1. So we get the standard form. Here the denominator of this x square is greater than the denominator of y square, which implies that the major axis or the foci lies on the x-axis, or the major axis is along the x-axis. So on comparing with the equation x square upon a square plus y square upon b square is 1, which is the ellipse whose major axis is on x-axis, or the foci lies on the x-axis. So we get here a square equals to 9, implies that a equals to 3, b square equals to 4, implies that b equals to 2. Also we know that the c square, which is the distance of one of the forks from center, is a square minus b square, which is 9 minus 4, that is 5, which implies that c equals to root 5. So we know a, we know b, we know c. So we will find the foci. Now foci of this ellipse x square upon a square plus y square upon b square is 1 with coordinates plus minus c0. These are the coordinates of the foci. Now here c is root 5, which implies that the foci of this ellipse 4x square plus 9y square equals to 30 is plus minus root 5, 0. Now the vertices of this ellipse are plus minus a0, implies that plus minus 3, 0, because a is 3. Length of major axis when it lies on x-axis is 2a, that is 6. Length of minor axis, which is 2b, it is 2 into 2, that is 4. Now the length of lattice rectum of any ellipse is 2b square upon a, that is 2, 4 upon 3, that is 8 upon 3. Eccentricity of ellipse is c upon a, that is root 5 upon 3. Length of semi-major axis is simply a, because length of major axis is 2a, which implies that the length of semi-major axis is simply a, that is 3, and length of semi-minor axis is b, that is 2. So in this way we can find the vertices, coordinates of this foci, eccentricity, length of lattice rectum of any ellipse. So find the equation. And the second question is find the equation of ellipse with the given when the conditions when the constants are given, like when vertices are plus minus 5, 0 and the foci are plus minus 4, 0. We have to find the equation of this very ellipse. Clearly here the foci as well as the major axis lies on x-axis, because vertices are of the form of plus minus 5, 0, which implies that end points of the major axis are the points on x-axis, which implies that the major axis lies on x-axis, and the foci also lies on the x-axis, because on major axis foci lies. So its equation is of the form of x square upon a square plus y square upon b square equals to 1, where a greater than b. Now the vertices of this very ellipse x square upon a square plus y square upon b square is 1, which implies that are plus minus a0. Now the given it is plus minus 5, 0, which implies that plus minus a0 equals to plus minus 5, 0, because both are the vertices of same ellipse, which implies that a equals to 5. Similarly foci are equals to plus minus c0, coordinates of the foci of this very ellipse, which is plus minus 4, 0, implies that c equals to 4. Now here we need b. We know that the C, B and A are related by C square equals to A square minus B square, which implies that B equals to A square minus C square, that is simply B equals to 9, this B square equals to 9 or B equals to 3. Hence substituting A square equals to 25 because A is 5, B square equals to 9 in this equation. We get x square upon 25 plus y square upon 9 equals to 1 is the required equation of ellipse, with vertices plus minus 5 0 and the foci plus minus 4 0. Now the second one is, if the vertices are plus minus 0 plus minus 13, foci are 0 plus minus 5, we had to find its equation. Clearly the major axis is along the y-axis, hence its equation is of the form of x square upon b square plus y square upon a square equals to 1, where a is greater than 1, because we know that when the denominator of x square is less than the denominator of y square, then we simply say that its foci or its major axis is along y-axis. Here the foci of this very ellipse, standard ellipse, is 0, and these vertices are 0 plus minus 13, 0 plus minus a equals to 0 plus minus 13, which implies that a equals to 13. Similarly, foci equals to 0 plus minus c. These are the coordinates of the foci of the ellipse: x square upon b square plus y square upon a square equals to 1, which is simply c equals to 5. Now we need here b. So b and c, a and c are connected by relation b square equals to a square minus c square, which implies that b square equals to 144. Here a is 13, implies that a square is 169. Hence substituting a square equals to 169, b square equals to 144 in given equation, we get x square upon 144 plus y square upon 69 equals to 1. It is the required equation. Now the third one is major axis on x-axis and passes through point 43 and 62. We know that when the major axis lies on x-axis, then its equation is of the form of x square upon a square plus y square upon b square equals to 1 when a is greater than b. Now it passes through 4, 3. So substituting x equals to 4 and y equals to 3 in first, we get 16b square plus 9a square equals to a square b square. Name it equation second. Also it passes through point 62, which implies that on substituting x equals to 6, y equals to 2 in first equation, we get 36b square 4 9a square 4a square equals to a square plus b square. So from second and third, we have to find the value of a square and b square. Now solving this, because we can solve by adding, subtracting and multiplying, or by dividing, we get, or simply by the substitution method, we get a square equals to 52 and b square equals to 13. So let's substitute this a square and b square in first. We get x square upon 52, y square upon 13 equals to 1 is the required equation of given ellipse. Now the another problem is ends of the major axis, that the vertices of this ellipse are plus minus 3 0 and the minor axis 0 plus minus 2. We know that when the ends of the major axis or simply the vertices are plus minus 3 0, which implies that the major axis or the foci lies on x-axis. Hence when it lies on x-axis, this means that its coordinates, that is the coordinates of endpoints of this major axis, or simply the vertices, are 0 plus minus a 0 equals to plus minus 3 0, which implies that a equals to 3. Ends of minor axis 0 plus minus 2, which lies on this y-axis, because by coordinates are given, which implies that b equals to 2. Hence substituting in this equation, which is the standard form of ellipse, when the major axis lies on x-axis, is x square upon a square, y square upon b square is 1, which implies that x square upon 9 plus y square upon 4 is 1 equals to 1 is the required equation of ellipse. So in this way we completed this topic about ellipse. Inshallah, from tomorrow onwards we will discuss another conic section, that is hyperbola. So thank you.